So, to the first question that I am seeing on the screen, which is how do we decide whether the model is good fit or not? Okay, so to decide whether a model is good fit or not, we will report few indices. So we will report chi-square, okay, with its degree of freedom, right? And so, for example, in the solution that we got, we are seeing the chi-square is 34.57, degrees of freedom is 30, and p-value is 0.25, right? So what we will write is, we will write it something like this. We will say chi-square degrees of freedom is 30 point 30, I think it's 34.57, whatever it is, for degrees of freedom 30, and the p-value is equal to 0.258. Then the other chi-square, then the other fit index is chi-square by degree of freedom, which in our case is 1.15, right? And the usual rule of thumb, or the usual practices that you should look for, this is called as relative chi-square. Relative chi-square. Okay, this should be less than 2 or 3. It should not be more than 3 in any case. So we are seeing that this test is passing. Here the test is that the p-value should be greater than 0.05. So we are seeing that this is also passing. Then the next index that you can report is GFI, which in our case we saw it was 0.99 or 0.988. So we will report it to 2 decimal places. And the rule of model fit is it should be greater than 0.95. Then CFI, which is comparative fit index. This is called as, this number is very high, again 0.99. So we are seeing a good fit greater than 0.95. And then we report RMSEA, root mean squared error of approximation. Root mean square error of approximation. This is 0.02 in our case, right? 0.02. So this is, we will report it as 0.02, and the rule is that this should be less than 0.05 or 0.07, right? So these are called as fit indices. You will see that whenever chi-square passes, that means this one, this is the most important. If this passes, if this test passes, then you will see that all other tests will also pass. There is no chance that these tests will not pass. However, what is in my experience of doing structural equation modeling and CFAs, what I have seen is that when the models become complex, okay, when you have large models, then this test tends to fail. So for complex models, chi-square test fails. Okay, so what should you do in those circumstances when the chi-square test fails? Then what you should do in that case, report alternate fit indices and show that the alternate fit indices are doing well, okay, are giving you good results. And what are the alternate fit indices? The first one is relative chi-square, which is given by chi-square divided by the degrees of freedom. So in our case, it will be 34.57 divided by 30. Then the second one is you should report GFI, report CFI, okay, and report RMSEA. Some people also report SRMR, okay, SRMR. SRMR behaves similar to RMSEA, and the test is for SRMR is also less than 0.05. Okay, so if these passes, but at least you should report these four major alternate fit indices to show that your model is fitting well with the data. And how do you write? You will say that when your model that you have fits with the data well, right? And then you will write it like this in your papers: degrees of freedom 30 is equal to 34.57, and then you will say the p-value was 0.258, semicolon, then you will say GFI was equal to 0.99, semicolon, you will say CFI is equal to 0.99, and you have RMSEA which was equal to 0.02, full stop. Right? So this is one statement in your paper where you will say that when I did my CFA, the CFA fitted in past tense with the data well, and these were the fit indices, right? And yeah, so this is something that you should keep in mind. If this fails, that means if this is not passing, then you will add one more index, which will be chi-square by df, which was 1 point, in our case 1.6. You can add it right away. You can write this also, so you will put it somewhere here. Chi-square was this, chi-square by df was this much, and then GFI, CFI, and RMS. So a total of about 5 to 6 fit indices are usually reported in papers, right? Okay, Rachna, you mentioned that reliability analysis you performed on data and reverse coded items were not supporting the results. So go ahead and drop those items. So if you have items that are not working well, that show you negative item to total correlation, then those are the items that you should drop from your considerations. Surabhi, generally speaking, how long would complete exercise for developing a skill take? Well, let me tell you, if you are developing a skill, okay, I have told this 2-3 times. You will. It is good enough work to be pursued in a thesis. So let me tell you that if you are developing a skill, you will have to think about collecting at least 3 samples, 3 different samples of data, right? The first sample 1, is where we can call this as a pilot. You will do reliability. Remember, this is different from, this is after you have interviewed people and generated items, right? So that could be called as study 0. Okay, so or maybe let me call this as actually, let us call this, let me erase all of this. So on sample 1, what you will have to do is you will have to understand, construct, okay, you will have to interview people, conduct interview, okay, you will conduct interviews or FGDs, focus group discussions, and based on this you will generate items, right? And also construct definitions. Okay, then the second one, after you have done this, you will do sample 2, which would be pilot initially. Okay, and remember here itself you will also do, after sample, once you have items, you will also administer it to 3-4 experts, at least 3 experts, to check the face validity of the items. Then sample 2 you will collect, pilot, check alpha, okay, whether it is behaving properly or not. And on the same sample again you will collect more data and perform exploratory factor analysis, right? So you will do EFA, understand dimensionality, okay, and based on the dimensions you will perform reliability of the underlying dimensions. Then you will go to next sample, which is sample 3, where now you will do collect data again, and now you will do confirmatory factor analysis. What will you do in confirmatory factor analysis? Like we did yesterday, you will test the measurement model or confirmatory model, measurement model. You will confirm the factor structure, okay, and you will compute composite reliability, ABE, and test for convergent, discriminant, and now there are some people who like the paper that I had given you on family role performance. They collect a sample number 4 also, where they check for nomological validity. Okay, but you can test that here itself, nomological validity, or you can decide to go to sample number 4, where you test the relationships. Now you can decide for yourself. This whole exercise is not a short exercise. This is a long exercise which will take you quite some time. So I would say, if you are thinking of developing a scale, at least a year or two is going to go in that. Okay? Torrent expected range of skewness and Cartosis. Well, we usually say the range for skewness is less than 2, plus minus 2, uh, but actually even there, what you should do is don't go by the range, you should go by the critical ratio that is given. Okay, uh, uh, that was there. So the Cartosis is said to be plus minus 3, skewness is said to be plus minus 2. So that is the kind of range that we are. So your query is regarding covariances in between exogenous variable and CBSAM through double-headed arrows in A modes. Does it help to set apart correlation and give actual beta values for? Uh, so you see, Pragya, when we do our models, uh, whenever there are independent variables, we always allow them to covary. So these covariances can come out to be, or correlations can come out to be small, or correlations can come out to be high. So as a matter of design, as a matter of practice, between independent variables, if you have, for example, if you have three factor 1, factor 2, and you have factor 3, okay, and these are your independent factors. So you will always model and you will always see if these factors co-vary with each other, because once you model this covariance or correlation, you actually get to analyze whether they are distinct from each other or not, distinct, or is there multicollinearity. If you don't, because if there is multicollinearity, amongst your x variables, then when you will have your y variables, okay, and you are trying to test these correlations, okay, or sorry, test these betas, these are, this is beta 3, this is beta 2, this is beta 1. So this is regression path coefficient 1, path coefficient 2, and path coefficient 3. If these come out to be non-distinct, then what will happen is you will have problems of multicollinearity and you will not get proper regression coefficient. So when you have multicollinearity, which we will also do today, you have two options in CFA. If you have multicollinear factors which are not distinct, then factors are not distinct, okay, the independent factors are not distinct, okay, what you need to do is there are two options. Option 1, you collapse all the factors. So you create one big factor F, and you say that I will load all the items. If there were 10 items, so for example, we have 10 items in our leadership scale, I will load all items on only one factor. I will not model 3 different factors. So this becomes single dimension overall. And then that is one way. And the second way is option 2 is that you do hierarchical. We call this as hierarchical CFA. We'll do it just now when we are going to do work with our leadership factor, leadership construct. So we'll say that there are 3 factors F1, F2 and F3, each having their own separate items. Right, each having their own items. Now what I will do is, because they are not distinct, I will model a second order latent factor which is going to cause these. Okay, and for all my analysis I am going to work with this factor. I'm going to work with this factor. Okay, this is called as second order latent factor, and this is called as the first order latent factors. So that is why it is necessary that you first check, and therefore when you are doing analysis, allow them to co-vary so that you understand whether these are distinct or not. Okay. Lekha, AV of a factor would be low when, remember AV, what did we do yesterday? We said AVE is dependent upon lambda squares. So AVE will be less when the loading of the item on the latent factor is less. So actually, if the loadings, if the lambdas, you see, if the lambdas are less than 0.7, what will happen? Lambda square will be less than 0.49. And that is one of the reasons why people say that your lambda, the loading of the item on the latent factor, should be 0.7 or more. If your lambda...
Vishal, Lekha has to say something. Can I just unmute her?
Yes, yes.
So, sir, my doubt is on another aspect, so I don't want to disturb this flow. Can you just clear this, then I'll ask my second doubt.
Okay.
Yes. So what I'm saying is that if your lambda squares are less than 0.49, then your AVE will be less than 0.50. And so therefore, AVE is dependent upon loading of the item. Yeah, go ahead. Can increase in sample size? No, increase in sample size will not work. Okay, because this is a characteristic of the item. And if you have a poor item, no matter how much data you take, it will not work. Right? So what you will have to do is you will have to drop items having poor loadings. Okay. Yes, you can drop items during CFAs. Okay, you can. It is perfectly fine. As I just mentioned, if your lambdas are low, you drop those items and work with it. We will do it right now. Okay, when we will do CFAs for procedural justice, CFA for creativity, we'll look at it. Okay. Yes, you can, Asha, you can use different samples. You can, for pilot, you can do it on students. That is perfectly fine. Even for CFA also you can do. It all depends upon that those samples should be appropriate for the construct. So for example, if you are talking about leadership, right, and then you are asking students to fill data on leadership. Now that is an inappropriate sample, because students are not working in an organizational context. So they will not be the right people to respond to questions on leadership. If you are interested in leadership, then your samples, even pilots, should be from organizational context. But if you are looking at something like personality, attitude, for which students are also appropriate, yes, go ahead and get data from. Okay. So Anshu, this I will see if I get time, but moderation is not something that uh, I wanted to cover here. That is a different thing in terms of regressions, but we'll see. Maybe I can take that question. No, Praveen, there is no norm about Mahalanobis distance. We only see that the distance, if there is any case which is significantly different from other cases, that is a uh, sort of that is a case which we can identify as an outlier and drop. So there is no such uh, norm for this. Okay, everybody, please read that doing SEM with Amos. Okay, the PDF book, and in that book, she explains each one of these things. So the book has a chapter on how do you interpret Mahalanobis distance, how do you, so this book that I was mentioning yesterday, okay, so if you look at, let us, yes, so if you look at this, okay, assessment of multivariate outliers, page number 106, okay, typically an outline case will have d squared value that stands distinctively apart from all other d squared values. Okay, so this book gives you good descriptions on what should you do and how you should understand and interpret these these things. Okay, something that I have told you, but if you want to know more, you can read this book and understand. Service quality is first order construct. No, Parvesh, service quality is actually second order construct. The first order constructs would be the dimensions of service quality. The rater are zero order. Raters are, I think you are talking about observed items, or the items. Items will be your observed variables. So the dimensions of the service quality construct will be first order, and the overall construct of service quality will become second order. No, Lekha, you gave a rationale for multicollinearity and just build it up. And yes, if you, for example, if you look at construct like transformational leadership or engagement, I think it is pretty established in the literature that dimensions of transformational leadership are highly correlated. And therefore, if you look at papers, they will all model a second order latent factor like this. Okay, they will all model a second order latent factor, something like this, and then work with it. So yeah, there is a lot of literature also which shows that people work with constructs where the underlying factors are highly correlated by modeling an overall second order construct. And if we are adopting established scales, whether we can take second order factor. No, see, this is not a question of adopting scales or not. This is about testing what is coming out in terms of correlation between factors. So you will first start out, remember, you will always start out by modeling first order factors. Something that we did yesterday when we were doing our Amos one. You will always test what is the correlation between these. And then if they are not discriminant, you will model the second order latent factor. Okay, so that is. Yeah, so 12. What you can do, Dr. Richa, is you can do parceling, okay? And I will talk about that. So just hold on to this question, and so if you have large sample, large number of items, go for item parsing. Yes, it is perfectly fine, Toran. You can go for convenience sampling uh, for your pilot. Even for samples 2 and 3, you can go for. Can we add moderating variable in a scale? No, you cannot do. Moderating variables are distinct variables, right? They are distinct constructs. You don't add moderating variables to your own scale. Okay? They will be separate construct in the overall mode. Okay, so let us now go ahead. So